Did you know that we mine ore with very low percentage of copper in it? Then we have to refine that copper so that it can be used in electrical appliances. Hi, today we're going to talk about the loss and gain of electrons in chemical reactions. So making metal useful. Metals are an important resource, but pure metals are rarely found in nature. The term ore refers to a rock containing enough useful metal to be mined, such as iron ore. A metal is typically made of cations surrounded by free-floating electrons. So these are positive ions with free-floating electrons around them. And again, those free-floating electrons allow metals to be malleable. Some of these electrons will be lost to other atoms in the environment. And then the number of free-floating electrons is no longer going to be equal to the number of protons or positive charges in that metal. Now those metals that have now lost electrons are going to become positively charged. So a calcium atom has 12 protons and 20 protons and 20 electrons for a net charge of 0, where a calcium ion has 20 protons and 18 electrons for a net charge of 2 positive. When that ionic compound is forming, atoms that pick up the extra electrons become negatively charged ions, and positively charged ions are now going to be attracted to those negatively charged ions, and an ionic bond will be formed. So phosphorus atom with 15 protons and 15 electrons has a net charge of 0, where a phosphorus ion has protons of 15 and 18 electrons for a net charge of -3. So this will be a negatively charged ion attracted to a positively charged cation. So there's an acronym that's LEO says GER. So if we lose electrons, oxidation occurs, and when we gain electrons, reduction occurs. So when an atom loses an electron, it is oxidized. So atoms that lose electrons become positive. Oxidation is going to be a chemical process when that typically metal atom loses electrons, becomes positive, and becomes a cation. There's two different types of oxidation reactions. One can be when a metal atom forms a metal ion and some free electrons. The other is when a non-metal ion that has a charge becomes a non-metal atom, and then electrons are freed to the environment. So we had a negative chlorine atom becoming, or negative chlorine ion becoming a chlorine atom and releasing 2 electrons to the environment. Reduction occurs when an atom gains electrons. There's two different types of reductions. One is when a metal ion, which has a charge that's positive, needs to gain electrons to then become a metal atom. Or when a non-metal atom, which is neutral, loses electrons or gains electrons to become a metal ion. In order to get a valuable metal out of our ionic compounds, a less valuable metal can be used to take its place in that compound. So we're going to replace the valuable metal that we want with a less valuable metal. So in a single replacement reaction, an element is going to react with a compound to produce a new element in a new compound. This means there are 3 elements involved altogether. One will be oxidized and lose electrons, one will be reduced and gain electrons, and one will be the spectator because it won't gain or lose any electrons through that chemical reaction. So silver is found as the compound silver sulfate, but we want to collect the pure silver. So we need to react silver sulfate with zinc metal to produce zinc sulfate and pure silver. So in this chemical reaction, zinc is going to lose electrons and become oxidized and is oxidized. So we went from a zinc solid on the product reactant side to zinc ion plus 2 electrons on the product side. Silver is going to gain electrons. It went from a silver ion plus 2 electrons on the reactant side to solid silver on the product side. Sulfate will be unaffected and is the spectator ion because sulfate in the reactant side and sulfate in the product side show us that there was no exchange of electrons. A reaction that includes both reduction and oxidation is called a redox reaction. Thanks for joining us for today's lesson. Catch you next time.
If you enjoyed this video, check out our website online.plrd.ab.ca and visit us on Facebook, Prairieland Online Academy. You can find out all that's going on with Prairieland Online Academy.